Welcome to the Personalized Immunotherapy Research Lab or PEARL YouTube channel. I'm Stephen Vensko from the Vincent Lab at the University of North Carolina at Chapel Hill, and I'll be your guide today. In this video, we're diving into a framework we built called RAFT, which is an acronym for Reproducible Analyses Framework and Tools. We'll be covering three main topics. First, an overview of RAFT. Second, our motivations for building RAFT. And third, the 5 development principles that shape how it works. At its core, RAFT is a command line tool built in Python and designed to work with Nextflow DSL2. It acts as a wrapper to simplify and enhance the experience of working with bioinformatics workflows. We began developing RAFT back in late 2019, while the DSL2 syntax was still in preview mode. Our aim was to make Nextflow more user-friendly and to support building modular workflows, especially for neoantigen prediction. While RAFT shares some similarities with the NF Core framework, it's a distinct system with its own goals and design choices. Let's walk through the 5 key development principles of RAFT, which are a project context, broad tool and workflow support, off-the-shelf workflows, modularity and extensibility, and project-level reproducibility. Principle number 1 is a project context. Bioinformatics can be messy. We've all seen untracked scripts and scattered output files that only make sense to the person who wrote them. RAFT addresses this by creating a structured project each time you run a workflow. Each project has its own unique ID and folder that stores everything: fast queues, logs, modules, metadata, references, and the workflow outputs. This structure makes it easier to rerun analyses, trace results, and stay organized, all from a single, centralized directory. The second principle is broad tool and workflow support. As of this recording, RAFT includes more than 115 public modules. These modules cover a wide range of tools, such as read aligners and workflows for tasks like RNA quantification, variant calling, and HLA typing. These pre-built modules are designed to be combined and reused, making it easier to assemble workflows for all kinds of analyses. Principle number 3 is off-the-shelf workflows. Not every user wants to write their own pipelines from scratch, so we created a mode in RAFT called Run-ODS, short for Run Off the Shelf. This mode automates the process of building and launching a workflow. It creates a project, loads modules, downloads references, builds the workflow, and runs it with Nextflow, all from a single command. These off-the-shelf workflows come with sensible default settings, so new users can get started quickly. Principle number 4 is modularity and extensibility. We wanted advanced users to be able to customize every part of their workflow. RAFT lets you change which tools are used and tweak their parameters. You can edit the main.nf workflow file directly or provide a user parameters option to RAFT to override defaults. You can even create your own tool-specific modules and plug them into the RAFT ecosystem. More on that is available at useraft.io. And finally, principle number 5, project-level reproducibility. RAFT uses the project structure we talked about earlier to bundle everything into what we call a RAFT package. This package contains all the files, modules, parameters, and metadata needed to reproduce a workflow later, even on a completely different system. You create it with RAFT's package project mode, and reload it using RAFT's load project mode. It's a simple and powerful way to ensure long-term reproducibility. And that's a wrap on this introduction to RAFT. Thanks so much for watching. If you found this video helpful, be sure to like, subscribe, and hit the notification bell so you don't miss future uploads from PEARL. If you have questions or want to see a deep dive into a specific RAFT feature, then please drop a comment below. We'd love to hear from you. Until next time, take care and happy analyzing.